Hey, welcome to The Explainer. You know, we're surrounded by metal every single day, in our phones, our cars, even our jewelry. But have you ever stopped to think about how we get it? How we turn a chunk of rock into a polished, usable ring? Well, that's exactly what we're going to dive into. Seriously, think about it. Where does all this stuff actually come from? The answer is pretty wild. It's usually right there, under our feet, in the ground, but it looks absolutely nothing like you'd imagine. And this is the whole challenge right here. On the one hand, yeah, sometimes you get lucky and find a beautiful, pure gold nugget just sitting there, but that is so incredibly rare. Most of the time, the metals we need, like aluminum, are locked up inside these dull, boring-looking rocks, like this piece of bauxite.
So, that brings us to our first big chapter, metals locked in rock. This whole thing is basically a giant scientific quest, a mission to figure out how to break that pure metal out of its rocky prison. And of course, there's a name for this science.
It's called metallurgy, and you can think of it as the complete instruction manual. It covers everything, the science, the technology, the entire process of going from a worthless-looking rock to a super useful purified metal. It's a huge deal, and it all starts with finding the right kind of rock. And that special rock is called an ore. Now, an ore isn't just any old rock with some metal in it. It has to have enough of the good stuff to make the whole, very expensive process of getting it out actually worth it. This is our raw ingredient. But unfortunately, it comes mixed with a whole lot of garbage. And yeah, even the garbage has a name. It's called gangwei. Weird word, I know. But it's just all the worthless sand, dirt, and other bits of rock that are mixed in with the valuable ore. So logically, the very first step is figuring out how to get rid of it. Which leads us right into part 2, the great separation. This is all about tackling that first big challenge. How do you separate the good stuff from all that junk?
The process is called concentration, and the goal is simple. You want to up the percentage of the valuable metal by physically getting rid of all that gang. And scientists have come up with some really clever ways to do this, by playing on the different physical properties of the two materials.
One of the coolest methods is basically giving the ore a bubble bath. You grind it up, mix it with water and some pine oil, and then you blow air through it. Now here's the clever part. The tiny metal particles, they hate water. They're hydrophobic, so they cling to the oily air bubbles and float to the top in a froth. The worthless rock gets wet and sinks. Then you just skim the metal-rich froth right off the top. It's brilliant. Okay, on to our third section, unlocking the metal. So we've gotten rid of the sand and the dirt. Awesome. But now we have a way bigger problem. Our metal isn't actually pure yet. It's still chemically stuck to other elements, like oxygen or sulfur. We have to somehow break those chemical bonds, and the method we use, the entire strategy, depends completely on the metal's personality, specifically how reactive it is. You know, how badly does it want to stick to other elements? The answer to that one question tells us everything we need to know. And this right here is the master plan. It's the reactivity series. Metals at the top, like aluminum, are super reactive. They cling on for dear life, and you need brute force to get them apart. The metals in the middle, like iron, are a bit more reasonable. You can coax them apart. And the ones at the bottom, like gold and silver, they're so unreactive and chill, you often just find them pure in nature. So for those really clingy, highly reactive metals, we have to bring out the heavy machinery. We use a process called electrolysis, which is basically just zapping the compound with a massive amount of electricity. The current is so powerful, it literally rips the chemical bonds apart, forcing the pure metal to break free. Now, for those metals in the middle, like iron, we can be a bit more subtle. It's more about clever chemistry. We usually start by roasting the ore to turn it into a metal oxide. Then we smelt it, which means heating it up in a furnace with carbon. See, the oxygen is more attracted to the carbon than the iron, so the carbon just waltzes in and steals the oxygen away, leaving pure iron behind. And don't underestimate the power of these reactions. They can be incredibly intense. Take the thermite reaction, where aluminum steals oxygen from iron oxide. It creates so much heat so fast that the iron becomes molten instantly. I mean, it's hot enough to weld gigantic steel railroad tracks together right on the spot. That's some serious power. So we did it. We fought the battles, we have our pure metal. You'd think the story ends there, right? Nope. We've just created a brand new problem for ourselves, because now nature wants its metal back. And we call that process corrosion. It's just the natural tendency for these pure metals to react with air and water and try to get back to that more stable compound state they were in when they were a rock. And you've seen this everywhere. The reddish rust on iron, that green layer on old copper statues, the black tarnish on silverware. It's a constant chemical battle. Which brings us to our last section, stronger together, the fix. Now that we know the enemy is corrosion, let's look at the brilliant ways science has figured out how to fight back and protect these metals we worked so hard to get. Here's a classic example. Problem: iron rusts way too easily. Solution: we galvanize it. We just coat the iron with a thin layer of zinc. Now, zinc is actually more reactive than iron, so when moisture hits, the zinc corrodes first. It basically sacrifices itself to protect the iron underneath. It's like giving the iron its own personal bodyguard. But probably the best defense of all is a good offense. Instead of just putting a protective coating on the metal, what if we could change the very nature of the metal itself to make it stronger? Well, we can. We do it by creating a whole new type of material called an alloy. And this is a perfect example of an alloy in action. Stainless steel is still mostly iron, right? But by mixing in very specific amounts of other elements, like chromium and carbon, we create a completely new material. This specific recipe makes it not just strong, but incredibly resistant to rust. We fundamentally changed its character to win the fight. So when you look around, the big takeaway is this: the metals that build our entire world aren't just dug up from the ground. They are one. They are the prize at the end of a long, difficult, and brilliant scientific fight. And it really makes you wonder, right? What other hidden sciences are all around us, quietly powering our everyday lives?